Okay, so essentially, we want to break up n into an increasing, non-decreasing sequence of positive integers where... Okay, that's interesting. So the last condition is that a sub k is less than or equal to a1 plus 1, which means that basically we only have two possibilities. So essentially, there's some point, all of these numbers equal and all of these numbers have to be equal, and they're just one apart. So like we have like 4, 4, 4, like 5, for example. So how many ways are there to do that? Well, see, essentially, so I'm fix n and then see how many there are for each k. So for k equals 1, we always have 1. For k equals 2, essentially essentially they're equal or they differ by 1. And this is just solely dependent on whether n is even or odd. So there's 1. Okay, so k equals 3. I'm wondering if this is some sort of inductive method to do this. So for k equals 3, okay, first of all, so essentially consider the case where they're just all the same. So you have k numbers and they're all equal. Say, yeah, they're just all equal a. Then the number would have to be a times k. So I think there's only one way for each k, because this number is divisible by k, and n has a unique remainder mod k. So we can definitely find a construction. So if what I want to know is, for a given n and a given k, is the sequence uniquely determined? So I know that, so just basically let the a's start from the floor of n over k, yeah? And then the remainder, we're just gonna add 1 to all of these. So let's say, take an example, n equals 13. We have, let's say k equals 4. Okay, then we're gonna have 3, 3, 3, and 4, yeah, because you take this floor. Okay, and I think this is, so this is definitely a solution. Is this the only solution? Well, we can think about, well, n is definitely bounded between this lower bound and then this next. So if all the a's were equal to 4, this would be too high. If all the a's were equal to 3, this would be too small. What if it lands exactly? Is there a good argument to see that this is unique? Okay, so by the division algorithm, there exists a unique k and a unique r such that this is true. So if we set a to be this and then add 1 to the last r of them, this will satisfy the condition. Now, does this uniqueness theorem imply that the sequence is unique? So if we choose q minus 1, then so say we chose all 2s, and then we want to add 1 to some of them. So maybe some of these are 3s. Would that be possible? No, because this would be too small. And that's because this would be less than this in the first place. So if some of these were 4, that means that all of them are at least 4. So if the smallest, yeah, so if the first number is a, then this total sum has at least ka. If the biggest number is a, then the total sum is less than or equal to ka. And we know that n is equal to kq plus r, and r is between 0 and k. So this means, like, I'm fairly sure this is right. I just want to confirm. Yeah, so if a is strictly less than q, then this would be strictly less than qk plus k. Okay, so if k is at most q minus 1, then this would be at most qk. And then you have a maximum of k that are 1 less, but that's, yeah, so this is unique. So for each k, there's a unique representation. which means that for n fixed positive integer, we can have k ranging from 1 to n, and it works for the given example. So the answer is just n.